In this video, we are going to do more antiderivative. The first problem is f double prime of x equals to 2x plus 3 times e to the x is a double prime. We are looking for f of x. All right, so let's do the first undo. F prime of x, so this one is 2 to the x raised to the first power, right? Okay, then we do 1 plus 1, and then put the 1 plus 1 in the denominator. The 2 stays on top, and then the e to the x, that doesn't matter how many times you take the derivative, is always e to the x, and then don't forget we have a plus c. So f prime of x equals to 2 divided by 2 is equals to 1, so we have x squared, and then plus 3e to the x plus c. That is the first undo, first antiderivative. So to get to the f of x, we have to do the antiderivative again, and then f of x, this is a x2 plus 1 divided by that, and then e to the x is still e to the x, and then c is a constant, right? You take the derivative of that is equals to c times x. When you take the derivative of cx, a constant times a variable, let's say 5x, 10x, the derivative is just equals to the constant value, right? So since the letter c is used for another constant, we will use another letter d. So f of x equals to 1 over 3 x to the third plus 3e to the x, and then plus c to the x plus d is the it's not the antiderivative, it's an antiderivative, the general solution of the double prime. Right? This is called a general solution because we haven't determined the constant c and d yet. Next one, switch color for the next one. So the next one is f triple prime, number 2, triple prime of x equals to 12 plus sine of x. Okay, the first derivative, the first undo, double prime, that is equals to 12x, right? Because when you take the derivative of 12x, you get back to 12. And then the antiderivative of sine is negative cosine, right? Because when you take the derivative of cosine, you get a negative sign. But we have a plus sine x, then that means you have to prepare a negative in front of cosine. And then plus c, so that is the first undo. The next undo is f prime of x. So this is x 1 plus 1, right? And then 12 divided by 1 plus 1. Do you have to show your work like this? With some practice, you don't need to do the work like this anymore. And then the derivative of sine is equals to cosine, no negative, so that's why the minus stays there. And then plus the derivative, antiderivative of c is cx, and then we use another letter to represent constant d. And then this is equals to 12 divided by 2 is 6, x squared minus sine x plus cx plus d. So that is the first derivative. And then last undo, f of x. So this will be x2 plus 3, right? No, 2 plus 3. 2 plus 1 equals to 3. And then we have the 2 plus 1 in the denominator. This is a 6. And then the derivative of what is equals to sine. Is this a cosine? The derivative of cosine is negative sine. So since we have a negative right there, then this must be a plus. So when you take the derivative of cosine, you get a minus sign, right? So plus minus, that gives you this minus. And then plus cx, so cx, be careful. So this will be x squared, right? And then we have a c divided by 2. Take the derivative of this, then you get the cx. And then the d becomes a dx, and then we need one more letter to represent the constant, so that will be e. So overall, f of x equals to 6 divided by 3 is equals to 2. So we have 2x to the third plus cosine x, and then plus c over 2 x squared plus dx plus e. So that is the general solution. So that is number 2. Let's move on to number 3. We switch color for number 3. Number 3, we have f of x equals to 2 minus x plus x to the 5th divided by x squared. So first, let's break this down into three fractions. 2 divided by x squared minus x divided by x squared plus x5 divided by x squared. And then we break this down into three pieces. So the first piece is 2 divided by x squared. So that is f of x equals to 2 times x to the negative 2. And then this is x to the negative 1. And then this is x5 minus 2 is equals to 3. And then when you find the antiderivative, one formula that I would like to remind you is the derivative of ln x is equals to 1 over x, which is x to the negative 1. So when you do the antiderivative of x to the negative 1, then you get your ln x. Otherwise, so this is a wrong answer. So let me show you the wrong answer. So the wrong answer is when you take the antiderivative of this, you go like that, x negative 1 plus 1, and then minus 1 divided by negative 1 plus 1. What do you get? You have a 1 divided by 0, and then x to the 0. There is no way to determine what that is. So this is completely wrong. When you do that, no credits at all. Let's go back to the right answer. F of x is equals to 2 times that, so that will be 2 divided by, we haven't done the antiderivative yet, right? So antiderivative, so that will be x to the negative 2 plus 1, negative 2 plus 1, and then 2, and then the minus is a minus. The antiderivative of x to the negative 1 is ln x, and then this is a x to the 3 plus 1, 1 divided by 3 plus 1. And then we clean up the coefficient. F of x is equals to negative 2, x to the negative 1, so that will be just this, right? And then minus ln x, and then plus 1 over 4, x to the 4th. Can you use negative exponent? You have to read the direction of the problem. Sometimes they don't allow you to use negative exponent. You have to read the problem. Okay, so that will be number 3. Oh, actually, you know what? This is the number 3 of the previous problem. So in this problem, I actually have a different number 3. It's fine. It's fine. So this one, I actually solved a problem in the previous example. So this, we are not going to erase anything. This is a good practice. It's a good practice anyway for the antiderivative of x to the negative 1. So let's do the number 3 that I put in this example. If you want to find out what that number 3 is, you can go back to the beginning of the video to find out. So that number 3, so let me switch color. So this is a real number 3 of this problem. So number 3, we have f prime of x equals to 4 divided by 1 plus x squared, and then they gave me some sort of like a domain, right? So 0, x is between 0 and pi over 2, and they gave me initial condition f of 1 is equals to 0. All right, so that means they want me to find the constant c. All right, let's start. So f prime of f prime. So first thing first, I have to rewrite that as 4 times 1 divided by 1 plus x squared, because here is a formula. The derivative of inverse tangent of x is equals to 1 divided by 1 plus x squared. So that means f of x is equals to 4 times inverse tangent of x and then plus c. Okay, and then here is the general solution, right? So this is called the general solution. And then for a particular solution, I have to use the f of 1 equals to 0. So we have f of 1 equals to 4 times inverse tangent of 1 plus c equals to 0. And then the inverse tangent of 1, so this, we have tangent of pi over 4 equals to 1, right? Do you still remember your unit circle? Why do I use pi over 4? Because other than pi over 4, there is another point in quadrant 3 that gives you a 1 as well. So that's why they gave me a domain for x. They want x to be between 0 and pi over 2. So that means when you look at your unit circle, we want quadrant 1 only. Unit circle, quadrant 1. X is between 0 and 90 degrees. Okay, go back to this problem. So we have this is tan inverse tangent of 1 is just equals to pi over 4. So we have to plug in pi over 4 to the inverse tangent. So that means 4 times pi over 4 plus c is equals to 0. So c is equals to negative pi. So my particular solution is f of x is equals to 4 inverse tangent of x minus pi. This is called the antiderivative, or you can call this a particular solution, or you can say the antiderivative. Moving on to number 4, we switch color for a new problem. Number 4, we have f prime of x equals to secant x times secant x plus tangent x, and then there is a domain for x. They want x between negative pi over 2 and past the pi over 2. So that means x is between, using in terms of the unit circle, is between quadrant 1 and quadrant 4. All right, quadrant 1 and quadrant 4. Negative pi over 2 is 90 degrees clockwise. Okay, let's do the distribution. F prime of x is equals to secant square x and then plus secant x times tangent x, and then f of x, the derivative of, you can look up the formula right now, the derivative of tangent x is equals to secant square. The derivative of secant x is equals to secant times tangent, and then this is a general solution, so we need a plus c. Did they give me a initial condition? Yes, they gave me that f of pi over 4 is equals to negative 1. So that means we have to find what c equals to. So at this point, the c is called an antiderivative, or you can call this a general solution. This line is called a general solution. Now let's get c. So f of pi over 4, that is equals to tangent of pi over 4, that is equals to 1, and then plus secant pi over 4 plus c equals to negative 1. So tangent pi over 4 is equals to 1. This is a c, this is a negative 1. And then secant pi over 4. So secant pi over 4, secant is equals to 1 over cosine, right? So that is the same thing as 1 over cosine of pi over 4. So if you look up the unit circle, at pi over 4, the x coordinate is x equals to root 2 over 2. So this will be 1 divided by cosine pi over 4 is root 2 over 2. So that means you have 1 plus 2 times root 2 plus c equals to negative 1, and then subtract negative 1, subtract 1 on both sides. This is a negative 2, this is a plus c, and then this one you can rationalize. How do you rationalize? The way you do this is you have 2 over root 2, and then you multiply top and bottom by root 2. This is called rationalize. Rationalize means you want to get rid of the radical in the denominator. So multiply that, you have a root 2, right? So overall, this is a root 2, and then c is just equals to negative 2 minus root 2. Do not approximate this, right? That's it. Negative 2 minus root 2 is fine. And then the particular solution is f of x equals to tangent x plus secant x, and then minus 2 minus root 2. So that is the answer we are looking for. And that is the end of number 4. Let's move on to number 5. So number 5, we switch to another color. Number 5, we have f double prime x equals to negative 2 plus 12x and then minus 12x squared. And then f prime of x that is equals to this. The first one is just negative 2x, right? The derivative of negative 2x is equals to negative 2. And then this, can you do this without the 12 divided by something? So this is 1 plus 1 is equals to 2. 12 divided by 2 is equals to 6. So with some practice, you should be able to do this without a lot of hassle. And then minus, this is x. 2 plus 1 is equals to 3. 12 divided by 3 is equals to 4. That's it. Plus c. And then there is a condition that f prime of 0 is equals to 12. Let's get the constant. So f prime of 0, so this is a negative 2 times 0 plus 6 times 0 square minus 4 times 0 to the third plus c equals to 12. So easy, c is just equals to 12. Then I am going to rewrite my f prime of x. That is negative 2x plus 6x squared minus 4x to the third plus 12. We are not done yet. We are looking for f of x. So f of x, that is equals to x. 1 plus 1 is equals to 2. Negative 2 divided by 2 is equals to negative 1. Plus 2 plus 1 is 3. 6 divided by 3 is equals to 2. Just take a quick look. Take the derivative. You will get back to the previous line. And then minus 3 plus 1 is equals to 4. 4 divided by 4 is 1. And then plus 12x. We already use c, right? Let's use a d. And then they give me a initial condition. In number 5, they gave me that f prime of 0. Oh, actually, f of 0 is equals to 4. So f of 0 is equals to 4. And then let's find what d is. So f of 0, so 0 makes everything so easy. Plus 2 times 0 to the third minus 0 to the 4 plus 12 times 0. Everything is just a 0. So plus d equals to 4. So d is equals to 4. And then you rewrite the f of x again. So f of x is equals to negative x squared plus 2x to the third minus x to the 4 plus 12x plus 4. That's it. So that is number 4. We have 2 problems left. Let's go ahead and finish those 2 problems. Number 6, we have f double prime of 0. Oh, not theta, double prime. Oh, yes, f double prime of theta. I was right. And then times sine of theta, and then plus cosine of theta. So first, we have to find the first derivatives. And then they also gave me an initial condition, right? They gave me that f prime of 0 is equals to 4. F prime of 0 is equals to 4. All right. The derivative of cosine is sine. Is this right? Nope. Forgot a negative. Because the derivative of cosine is equals to negative sine, right? But in the f double prime, there is no negative in front of the sine. That's why we have to add a negative in front of the cosine. And then this one, the derivative of sine is equals to cosine. We plus c, and then use the initial condition to solve for c. F prime of 0, so negative cosine of 0 plus sine of 0 plus c is equals to 4. Cosine of 0 is negative is 1, and then sine of 0 is 0 plus c equals to 4. So my c is equals to 5, and then my f prime of theta is negative cosine theta plus sine of theta plus 5. So that is the first half. And then the second half is you find the derivative of this. The derivative of sine is equals to cosine, but there is a negative in front of cosine. Then we have to put a negative in front of sine. And then the derivative of cosine is equals to sine, is equals to negative sine. So since this, I can put a plus right here, right? The derivative of cosine is negative sine, but this is a plus. If you put a plus in here, that is wrong. So the answer is, this is a minus when you take the derivative of cosine, that becomes a negative sign, right? So this negative and that negative gives you a positive. And then plus 5x, no, 5 theta, because theta is an independent variable. And then the constant d. And then you use the initial condition, f of 0 is equals to 3, right? F of 0 is equals to 3. So this is f of 0 equals to negative sine of 0 minus cosine 0 plus 5 times 0, and then plus d equals to 3. This is a 0, 1, 0, d equals to 3. So d is equals to 4. And then you have f of theta, that is equals to negative sine of theta minus cosine of theta plus 5 theta plus 4. So that is called the particular solution. Last one. Number 7. We have f double prime of x equals to e to the x minus 2 times sine of x. Okay, so f prime of x. I have an initial condition, right? F prime of pi over 2 is equals to 0. So the antiderivative of e to the x is e to the x, and then this is a 2 cosine x plus c. Double check my word. When it comes with sine and cosine, you have to be careful. The derivative of cosine is negative sine, right? But here is another negative. So if you have a negative negative, the f double prime is supposed to be positive, but the given is negative, then this must be a positive. And then you plug in the pi over 2. That is equals to e to the pi over 2 plus 2 cosine pi over 2 plus c equals to 0. Cosine pi over 2 is equals to 0. 90 degree, right? At the y-axis, x is equals to 0. So e pi over 2 plus 0 plus c equals to 0. So c is equals to e to the pi over 2 in negative. So my f prime of x is equals to e to the x plus 2 cosine x minus e to the pi over 2. And then let's find the f of x. So f of x, we have e to the x, still e to the x, and then the derivative of sine is cosine. And then this is a constant, meaning that all we have to do is we put an x in front of that, and then the other constant, c, is used already. I am going to use d. And then the next initial condition is f of 0 is equals to 3. So let's plug in a 0. I use 0 because when you plug in a 0 to x, most of the numbers got cancelled, so we don't need to deal with the arithmetic. E to the 0, and then 2 sine of 0, and then e to the pi over 2 times 0. See how easy that is? Plus d equals to 3, and then e to the 0 is not equal to 0. That is equals to 1 sine of 0 is 0. 0 times anything is 0, plus d equals to 3. So d is equals to 2, and then we write our very final answer. F of x is equals to e to the x plus 2 sine x minus e to the pi over 2x plus 2. And then we are all done. So that is the final answer. So that is all in this lesson. If you think my video is helpful to your study, please subscribe, give me a like, share this video out for me. I appreciate your help really, really much. I see you all in the next lesson.